Hello everybody, getting ready to do 3.2, lesson 3.2 of 6th grade math, part 1. Part 2 and part 3 are available here at this email, and I'll get those out to you. 3.2 part 1 today, and we have a 34-point skill sheet and classwork to do today. And we have 2 points here of notebook taking. Today's bell work, teachers, is writing a mixed number as an improper fraction. Here are the mixed numbers here, students, to write as an improper fraction. Give your students about 4 minutes to do this. Okay, welcome back, and we got, for our first one here, 2.5 would be 5 over 2 would be what you should get, students. And then 4 3/5 would be 23 over 5. And then for 3 4/9 it would be 31 over 9 is what you should be getting here. If you're not getting these, this is your example here on how to get these. 3 times 4 is 12 plus 3 would be 15 over 4. And then this is more of a stepped way of getting that. And then what's this one here? 2 5/7 would be 2 times 7 would be 14 plus 5 would be 19 over 7. For this one here. Into our lesson today, starting out with a notebook entry here, page 1. How do you identify opposites and absolute values of rational numbers? We're back into absolute value again. Positive and negative rational numbers. Recall that positive numbers are greater than 0. They are located what? To the right of 0 on a number line. Negative numbers are less than 0. They are located to the left of 0 on the number line. Okay, into a word problem here. Water levels with respect to sea level, which has an elevation 0, may be measured at beach tidal basins. Water levels below sea level are represented by negative numbers. So the table here shows water level at a tidal basin at different times during the day. Graph the level for each time on a number line. So here are our times A, B, C, D, E, and then here is the water level here. So how would you graph that here? Well, let's see how you would graph it. A, at 4 a.m., what's at 3.5? That'd be over here. Between 3 and 4, yes, is A, 3.5. And then B, where would you graph B at, students? It'd be here, B, 2.5. And then noon would be C, negative 0.5. Would that be over here? Be on negative, right? Be to the left of 0. Wouldn't it be there? Yeah, you know it would be there. And then 4 p.m., D would be negative 2.5. Where would that be? Negative 2.5 would be over here. This is negative 2, then a little bit further to the left of negative 2 would be negative 2.5, and then E would be 0.5. Wouldn't that be here? Yeah, it'd be there. So that'd be 0.5 for E. How do you know where to graph negative 0.5? Question. How do you know where to graph negative 0.5? It is halfway between negative 1 and what? 0. Negative 1 and 0. This would be negative point. Wait a minute. Where's negative 0.5 at? Yeah, it's right here. This is negative 1, and then this is 0, so it'll be right there. It'll be negative 1 and 0. Yeah. We got it. Okay. So classwork page 3 here. Those were plots of sea level. At what time are times the level closest to sea level? How do you know? Noon and 8 p.m. there are each 0.5 units from A. So we have one here that's 0.5 from a 0. And then negative 0.5 is the same distance from 0 as each other. Which point is located between negative 3 and negative 2? Where's negative 3? Here's negative 3, and then here's negative 2 would be right here. So that would be D. Yeah. And then, which point is the same distance from 0 as D? So, what's the same absolute value as D? Was that negative 2.5? So we have something, 2.5 would be B, wouldn't it? Yeah, be right there. That would be the same absolute value as D is. Okay, classwork page 4, that was our plot again. How would you graph negative 2.25? Would it be left or right of D? So where's D? So it'd be negative 2.25. Where would that be? What was D? It'd be halfway between negative 2.5 and negative 2. So it'd be in between, be right about there, wouldn't it? Negative 2.25. Be right about there. Okay, classwork page 5. Rational numbers, opposites on a number line. You can find opposites of rational numbers the same way you found the opposites of integers. Two rational numbers are opposites if they are the same what, class? Distance from zero, but on different sides of zero. That's how you know they're opposites. They have the same absolute value, but different signs. So like this number here would be the same thing, have the same absolute value as that number, right? Because they're both the same distance from zero, right? Negative, 2 3/4 and negative 2 3/4 are opposites. Same absolute value, different signs. Yeah, we got that. We got that. Okay, onward here. Page 6, classwork. So example 1, until June 24, 1997, the New York Stock Exchange price value of share of stock in eighths, such as 27 1/8 or 41 3/4. The change in value of a share of stock from day to day, also represented in eighths as a positive or negative number. The table shows the change of value of A. So we have 1 5/8 and negative 4 1/4 on a day apart. The table shows the change in value of stock over 2 days. It graphed the change. So the stock value for Wednesday and its opposite on a number line. So graph the change in stock value. Okay, well let's graph it. The change in value for Wednesday is negative 4 1/4. And the graph point 4 1/4 points below 0. So we have 0 here. So it'll be 4 1/4 be down here somewhere, about there. So that would be the difference there. Okay, so here's our two plots here for the graph of the stock price. Negative 4 1/4 is the same distance from 0, but on the other side of 0. The opposites of negative 4 1/4 is 4 1/4 up here. So that'd be 4 1/4 up there. So, okay, we got that. The opposite change in stock value for Wednesday is 4 1/4. So negative 4 1/4 is between negative 4 and negative 5. It is closer to negative 4. So negative 4 1/4 is here. Your turn. What are the opposites of these numbers here, students? Go ahead and do what? We already did that. Here they are. Negative 7 is opposite of 7. 3/5, opposite of negative 3/5. Negative 2 2/5, opposite of that. And then negative 9 1/3 is the opposite of positive 9 1/3. Okay. Okay, Alberto's average running time for 100 meters is 17 1/2 seconds. Each day after he warms up, Alberto records his run time so he can compare it to his average time. So here's Monday's time, change of time 2 1/4, and then Tuesday is negative 1 3/4. So negative 1 3/4 would be over, see, 1 3/4 would be over here. So graph the change in time for Tuesday and its opposite. So we start over here at negative 1 3/4. And what's the opposite of negative 1 3/4? It'd be positive 1 3/4 would be its opposite. This is the original here. This is negative 1 3/4 would be over here. And that was lesson 3.2, part 1. Part 2 and part 3 is available here at this email. Just email me. I'll get those out to you, as well as worksheets, quizzes, and tests. Thank you.